The purpose of this video is to explain how to draw components when you have a force that is at some kind of angle or not already aligned with your coordinate system. So the example we'll start with is, suppose you have a box that's being pulled to the right by some kind of a string or rope, and that force is at an angle. And the very first thing you always need to do when you have a situation involving forces is to draw your free body diagram. So I know on this box I have a force of gravity, I have some kind of a force of tension, and I can already see that I have a force here that is not long enough. The force of gravity needs to be longer. And some amount of normal force, and maybe there's friction, so let's include that. The second step when working with forces is to always set up a coordinate system. So you need to decide what orientation your XY axes are going to have. So the object is moving to the right, and it doesn't explain at this point. We don't know if it's constant velocity or acceleration, but if it's accelerating, that would be to the right or left depending on the friction. So in the horizontal direction, if there's an acceleration, you always want to line up one of your axes with the direction of the acceleration if there is one. If there's no acceleration, it doesn't matter what you choose for axes, just choose something convenient. And in this case, I can see that I have three forces already that are either up and down or left-right. So it seems that a convenient coordinate system would be our traditional one, with positive x this way and positive y this way. The third step is to see if you have any forces that are not already aligned with one of the axes. So force of gravity is already aligned with the y-axis. Force of friction is always already aligned along the x-axis, and normal force is already aligned along the y-axis. This force, however, is pulling partly in the positive x direction and partly in the positive y direction. Okay, can you see that the rope is pulling partly upward and partly to the right? So what we need to find out, if you are going to be solving a problem mathematically using the sum of the forces equations for the sum of the x forces and the sum of the y forces, if you're going to be solving the problem mathematically, you need to know how much of this force is in the x direction and how much of this force is pulling in the y direction. So I'm going to explain in this video how to draw those components to be able to then calculate them. So let's go ahead and redraw our force vector a little bit larger. So here's my force of tension, here's my y-axis, and here's my x-axis. In order to find the components, you need to, from this point, project down to the x-axis. And one way to think about doing this is that you're drawing sort of a line here that is parallel to your y-axis. And then do the same thing. If your x-axis is here, draw a line that's parallel to the x-axis up here at the end of that force vector. Now we can see this makes a triangle, and we can see that if we start here at the base of the force vector and we go to the right, this amount from here to here is the x component of that force of tension, and it's directed to the right. So here is my x component, and I would call that force of tension x. Well, how much of this tension force is pulling vertically? That's going to be this part from here to here. So that component looks like this, and I would call that FTY. You could also look at the components using this part of this triangle or this part of the square. So if you started here and went up, you could say this is FTY, because that is exactly the same vector as this one, just drawn in a different place on the paper. but that doesn't change the vector. If the length is the same and the direction is the same, then it's exactly the same vector. And likewise, you could think of this from here to here as the x component of the tension. And what you'll notice is the x component is a vector, y component is a vector. If you add these two together, they're equal to that original vector that you started with. So the x component of the tension plus the y component of the tension equals this force of tension vector. And then you should know an angle from the problem, and that is this same angle here. To draw the diagram this way, I'm going to show you what would not be correct. It would not be correct to draw it like this. Okay, because that would be saying that your y component of the tension is pulling down and that your x component is pulling to the left, which is not correct. This string is pulling rightward and upward.